Hello everyone, welcome back. This is Anu here. In the previous video, I was discussing about the package manager. We have discussed about pip and UV. Okay. First one we have discussed is pip. The second one we have discussed is UV package manager. The UV is around 10 to 100x faster. Okay, 10 to 100x faster. So we are going to see the UV package manager in detail today. UV package managers today in detail, and we're going to see why it is so fast as compared to pip. Let's go ahead and explore why it is so fast. The UV package manager is so fast as compared to the remaining competitor in the market. We are going to see why it is so fast and why it is giving that much speed. Let's go to the speed comparison. If you see the speed comparison, UV is around taking around 0.8 second to install one package, whereas pip is taking around 6.8 second. That is warm cache and cold cache. Okay, let's go ahead and see what is meant by this pip warm cache, pip cold cache, etc. Okay, suppose from a real-time example, suppose if you want to prepare some food, we will go to kitchen and we see there is no onion. What we'll do, we will go to the grocery shop, buy it, come back and cook. This is called this is called cold cache. Whenever we found something is not available, it was to go to the main store and put it back. Similarly, for this pip, if that package is not there, it will go to the original package location, download it, and use it. Before using it, it will be saved in the global location. Okay, save in global location in your local system, and then use it. This is what the cold cache means. Once it is available in the cold cache in your local system, and the next time, okay, next time when we need to do the same process, or when we need to prepare in terms of this, in terms of in common terms, suppose next time we want to cook same food, we'll go to the pantry, take the onion, cook. This time it doesn't need to go to the grocery shop and put it back. Like the same way in pip, whenever we want to install new package in the new environment for the new project, it will go to the global location, in your system, fetch from there, and use it in project. This is what happened in warm cache. Warm cache means it is already available in your system. This is how this pip is working whenever there is a package not available locally and when it is available locally. Then that's why it is taking too much time to install some packages. Why this UV is so fast? First thing is we need to see what is parallel downloads. Let's go ahead and see what is meant by parallel download. Okay. Why is so fast? The first thing is parallel downloads. What is meant by parallel download? Suppose if you want to download some package using pip, Okay, I have some files in requirement.txt. Okay, .txt. What it will do, I have package 1, p1, p2, p3, p4. Or let's give the real name. I need, in this file I have numpy, pandas, request, first API. What the pip will do? Pip will do a sequential manner. It will go and download the numpy, then it will go and download pandas, then it will download request, then fast API. In between, it has also a lot of dependencies. Each application or each library will have a lot of other dependency packages will be there. It has to download. That's why this pip is taking too much time. Suppose one package is taking around 2 seconds to download. Altogether, suppose if I have four packages like this, four libraries like this, then it is going to take around 8 seconds to download all this package. Whereas when it comes to UV, I have the same request. What it is doing, it will do the downloading of these packages parallelly. Suppose numpy, pandas, request, fast API. As it is doing parallelly, altogether it is taking only 2 seconds instead of 8 seconds. If pip is taking 8 seconds to download all of them, UV is taking only 2 seconds altogether to download this package. That's why this UV is so fast as compared to pip. Let's go ahead and see the second property, why it is making so fast. Second property comes global content addressable cache. Okay, content addressable cache. What is meant by global content addressable cache? In Okay, if we want to know what is meant by this global content addressable cache, first of all, we should understand how pip and UV saving files. Okay, first of all, let's see pip. Pip, suppose if you want to use one package in different project, suppose I need to use numpy. I have project 1, project 1, project 2, project 3. Here we have VNV. Here also we have virtual environment. Here also we have virtual environment. What the people do, it will copy number here, it will copy number here, it will copy number here. So we have 3 copies of number here spanning across 3 different projects. Suppose if it is 30 MB, altogether it is around consuming around 90 MB, 90 MB storage in the operating system. Whereas when it comes to UV, it is having a global location. Okay, global package location. From the global package location, I have all the packages. Sometimes numpy will be there, pandas will be there, sklearn, request, fast API, all the packages are there. Suppose if you want to use in project 1, project 1, project 2, whereas when it comes to UV, we have this global package cache will be there. There all the packages are being downloaded. Numpy will be there, pandas will be there, different libraries will be available in the cache. We are just taking a link which is pointing to the original cache location. We are taking only the hard link which is pointing to the original location. We are not going to copy that particular file every time whenever we need to point that, or whenever we need that library to run our application. We are just taking only the hard link instead of copying this complete 30 MB file everywhere, or we are just passing only the hard link of this global cache location of that particular file. So that's why it is taking very less memory space as compared to the pip, and it is not going to download all the packages again and again to each and every virtual environment. This is how The UV is handling the package. The next point we need to understand here is content addressable. We have seen this is called global content addressable. We have seen what is the keyword this global means, right? We already seen what is meant by this global. Now we are going to understand what is meant by content addressable. Global and cache we have seen. Now we are going to see what is meant by content addressable. Because suppose the moment UV download some packages, okay, UV download some library, immediately for suppose if it is NumPy using SHA-256, it will create a hash value, and it is going to save that hash value. Save hash value. Whenever we search for some package, what UV look is UV is internally looking this hash value. UV internally looking this hash value instead of not the file name. Not the file name. What is this hash value is? Hash value represent the actual content of that particular file. Instead of the file name, it is looking at the content of the file. Whenever we have some request, it will look into the file content. If the file content is already available, it fetch from there instead of file name. That is what this content addressable means. And from the description, one more thing, it is mentioned as hard link. Okay, UV is using the hard link. What is meant by this hard link? Let's go ahead and see what does it mean. Hard link means we have the global cache. We have this global cache. We have the global cache where we have, suppose I have this package. Whenever we have some project 1, project 2, project 3, everywhere we are taking only the hard link of this one, hard link of this particular file. I am just passing the hard link here. Hard link of NumPy. It will be same here, same here. We are not passing the complete file name. Instead, we are just passing the hard link. You may know about what is meant by hard link, what is meant by soft link and all. That is what this UV is making so faster when addressing the package management. Let's go ahead and see the UV command that we can use while working with any of the projects. Okay, so this command we can divide in different section. Okay, let's go ahead and explore the UV commands. UV commands we can divide into 6 categories. One is project related commands are there. Then running commands are there. Pip compatibility commands are there. Python version, whether you want to install new Python version or remove some Python version, that is also there. The tools, some pip tool we can install using that one, that is the pip tools. Then useful flags also will be there. Let's go ahead and see. The first one is project related. Suppose this is my blank directory. I am going to initialize this project directory UV init. I'm going to give a new name for my application called my app. Let's see whether this works. It has initialized my application. See, it has created my Python version. This is the current Python version 3.14. There is main.py, project.yml file where we have this project name, version, description about the project, readme file, required Python version, and dependency list, and the readme file it has created. Then let's go inside this my app folder, cd my app, and in any project we may need to create some file called requirements.txt. Whereas when it comes to UV, there are 2 files we can see. One is requirements.in and requirements.txt. Let's create both of them. I will explain you why it is so important to create both of them. First of all, we create requirements.in. Requirements.in, and I'm going to give the details. Suppose NumPy, pandas, scikit-learn, fast API, request. Okay, let it be there. We'll come to this point later. Okay, let's go ahead and see what is the other command. We have initialized this one. Then the next command is UV add. If you want to add a new package and its dependencies into your VNV virtual environment, then we can execute this one. UV add request. I need the fast API version 0.111. If you execute this one, this will add a new virtual environment will be created. In that virtual environment, it will create all the required files will be installed. It has created all the dependency files. It has created a new EA virtual environment and it has added those files. This is what it is we add. And if you don't want this package, then we can do instead of, and we can just do uv remove. When we execute this command uv add request and with the dependency name, if the virtual environment is not there, it is going to create the virtual env, then it will add this packages. But when we remove this request or any package, it is not going to remove the virtual env. It will be creating, it will be removing only the required packages which need to be uninstalled. Okay, now it has resolved the 11 packages in 1 millisecond, audited 10 packages. When we execute the UV sync, it has resolved 11 packages while looking into this uv.log, and it has audited 10 packages. It is comparing both the files. And if you execute the UV log, it is going to resolve all the dependencies. If there is any missing dependencies there, which is already listed in the requirement.ts, it is going to install and it will check with the UV sync command. And when you execute this UV log, it is going to check all the required libraries that are being installed or not. If it is not installed, it is going to install those packages and keep updated with the latest package requirement. Then if you execute --- check, it will check all the dependencies has been resolved or not. Let's go ahead and see what are the commands available in running any projects or running any script. Main.py. Okay, it has run that main file and it has given the content. Let's see what is there in the main.py. Print hello from my application. That is the content. Suppose if you want to run it in isolated environment, then we have to give script name -- isolated. It will run this application in isolated mode. Another important command is uvx. Okay, uvx command, the following tools are installed. That is a direct secret. What are the tools installed that we can see from this uvx command? That is what we have seen in this running. We have seen uv run. Then we have seen uvx for the package install packages. Then what else we see? Isolated, to run any package in isolated mode. Then we are all using pip for a long time. What are the commands which we have used in pip? That also we can use in uv also. Only thing is we had to add a prefix called uv. Okay, add a prefix called uv. Then we have to give the remaining command like uv pip install blah blah blah. uv pip install package name or requirement.txt file, etc. Let's go ahead and see what are they. What are the pip compatibility command we have. This is the command we have to execute. If you want to execute any particular library using pip and uv pip install, it will give what is the syntax it will give. We have to give this either requirement.txt or the particular package name. Let's go ahead and give the package name fast api. Install fast api is adding one package in 5 milliseconds is already added. And if you want to remove, if you remove fast api, it will remove that that particular application and related dependencies. Install -r requirement.txt. Sorry, I have gone requirement.in instead of requirement.txt. Just cancel this one. That is a specific use in case of uv text. Let's install. It is installing this number package. It is already listed there. Let it download. Now it is installed. Suppose I have two files. What are the requirement I need? I will be keep on adding them in this requirement.in in case of uv. From this, before shipping to the production, what we can do is we need to create the requirement.txt. That is a standard format. We need to create this requirement.txt file from this requirement.in. What we can do is we can execute the command uv pip compile requirements.in in the output file as requirement.txt. Once execute, let's go ahead and see what it is going to create in this requirement.txt. Okay, it has created that file with all the dependencies and all. It is saying this file was auto-generated by uv through this following command uv pip compile. This is the command I have executed. Using that command, it has created all the required libraries included in this requirement.txt. These are the common commands related to compatibility, that is pip compatibility. Then we can go ahead with this Python version. We can install multiple versions of the Python using uv. Manage manage multiple Python versions. Let's go ahead and see how to do that. Suppose if you want to install Python 3.12 on this project, it can execute a UV Python install 3.12. Python 3.12 already installed. Suppose if you want to install multiple versions, just give a space and 3.13 space 3.14 space. Yeah, you can give multiple versions here. These are all installed. Then you can see UV Python list. It will list all the available Python versions in this system. See, these are all the available Python versions. 3.11, 3.12, 3.13, 3.14. These are all the available Python version installed on this system. Suppose if you want to find the interpreter location for a particular Python version, then you can execute UV Python find 3.11. It will give where this 3.11 Python 3.11 is installed. It is installed on this location, 3.11.14. Suppose any other version 3.12. Let's see as it's available 3.13. That's also available. 3.14, that is also available. And let's see 3.9 whether it is available or not. It is not available. That's very showing. Yeah. Then I need to show you one thing, that is pip version. This is the version I am using for this project. Suppose if you want to change this version, this is called the pinning. Pin the project version. UV Python pin 3.12. If I execute this command, it is going to change this version 3.14 to 3.12. Let's see. Incompatible with this required version. Okay. What about 1.3? That is also incompatible. Require Python value 3.14. Require Python value. That is in maybe in TYML. Okay, got it. Let's execute to 1.0. I'm changing the required Python version to 3.10. Now, if you see this one, 3.14, if you execute this one, 1.2, it has changed the version from 1.4 to 1.2. Suppose if you want to change the version to 1.3, it is changed to 3.13. This always depend upon what version we have given in this project.tyml file. If it is specified that is 3.14 greater than or equal to 3.14 and saved it, and if you see this Python version 3.13, it will throw exception. Okay, and we got to execute to 3.14. It will change to 3.14. Now, if you want to go back to 3.1 or 1 or 1.2, we don't allow it will throw exception because it is specified in this TOML file that the Python version should be greater than or equal to 3.14. If you want to use the lower version, we need to change this version here. Another important thing is we may need to install multiple tools to manage the Python program, Python project. Those are the tools. Let's see what are the tools available. That is UV tool list. We can see there are three to four tools installed. That is Direct Secret version 1.50, Hugging Face Hub so 1.7, pre-commit, rough. These are the tools I have used or I have already installed on my machine. We can have multiple tools we can install that depend upon the project requirement. Suppose if you want to install any other particular tool, that also we can install it. Suppose if you want to install, it will install that particular package. It's already installed. It is showing already installed. These are all the common UV package manager commands we use day to day when we go ahead with the development. Hope you enjoy this video and hope you find this is a little bit informative, and see you in the next video with another topic. Bye. Have a good day.